Uh, we'll get, we'll get started for today. Uh, Hope everyone's doing good. So today, um, oh yeah, we still have a couple people that need to present. But before we do presentations, I want to go ahead and teach the new topic for today. So let me share my screen. So today is day 8. Can you guys see my screen yet?
No.
What about now?
Yeah, now I see it.
Yeah, I see it.
Perfect. Okay, so today we're going to be learning about a new model called K nearest neighbor, KNN model. It's a type of machine learning model that we're going to be learning, and it's supervised as well. So what is the K nearest neighbor model? Well, the K nearest neighbor model is a supervised machine learning algorithm that classifies or predicts the value of a new data point based on the majority class or average value of its K nearest neighbors in the training data. Okay, so what does that mean? So let's take this example. All right, we were just doing presentations for our decision tree classes that we had previously. So the project you worked on, that's all. We're just doing presentations for that. Yeah, no worries. Okay. So let's take a real world example here. So right over here, we have our home. And right next to our home, we have 3 nearby restaurants, okay? And each restaurant has a different rating. Okay. Let's say the lowest rating restaurant is the closest, but the highest rating restaurant is the furthest away. Um, how this would work is it would go to the house really would fit the data point that is closer to it. So they're more inclined to go to this 2-star restaurant compared to this 3-star restaurant here because it's closer in proximity to the users or the people. So how does that work with machine learning? So today I'm going to be using this table as an example for what we're trying to do. So this is a KNN model, and I have two variables here, right? We have redness and crunchiness. So independent is crunchiness, and then dependent is redness. So X and Y. Then let's just put a random data point and move it over here. So how a KNN really works is similar data points are located near each other. It makes a prediction based on the proximity of this data point compared to the other data points here. So we have two fruit items, right? We have apples and bananas, right? How Canon works, it checks um which data point it's near to. So since it's closer to bananas over here, it's gonna be more likely classified as bananas, right? But for example, we had a data point over here, it's gonna be more classified as an apple. But what if it's here, right? How can we know? Because it's closer to this apple and this banana. It almost looks the same. How does a computer know which one to classify it as? Well, we're gonna learn that today. So, in simple terms, how it works is the KNN model believes that relative data points are close to each other, and that's how it makes its prediction, right? So, what if, for example, we're predicting in this case whether a fruit that we don't know what it is an apple or banana. That's the goal of this, right? So we're given data on the redness of the data and the crunchiness of that fruit. Okay. And let's say that point leads us to this. Okay, let's just say that's 7, 3 or something like that, right? 7, 3. Okay, and it's just gonna be calculating how close it is to all of the data here. So I'm gonna go more into that more in this class. So far, does anyone have any questions on what a KNN is? No? Okay. All right. So there's 4 steps for the KNN. The first step is to choose a value for K, which is the number of neighbors. So basically what that means is how many data points do you want to like really test? But I'll like go more into that in a second. And the second thing is we need to calculate the distance from the new point to all the other points in the data set. So basically what I was showing before, we need to calculate the distances between each of the points here. Um, then here we have to sort the distance next and pick the k nearest points. And then finally, we do a voting system using a classification or do an average system using regression to make the prediction over here. Okay. So let's get into the first step. The first step we do is we need to calculate the distance between each of the points here. So we can use that through a popular method called um, Euclidean distance. Like, I'm not sure if I said that word right, but it's this formula that we can use to calculate the distance between this data point and the different fruits we have. So we're given X as the new input. So we have the input data that we give it, right? So that's that. Then we have our training point over here. And if who remembers what a summation does? Anyone want to give it a go on what a summation does?
Doesn't it add?
Yeah,
Yeah.
yeah, good. Yeah, it adds all the different points, right, that we have. So we add in the input data, right? This data, and then training data. This is our training data, right? We're adding all of these until we find calculate the distance between them like this. Okay. That's all there is to it. Nothing too complex. You just need to understand how the formula works here. Um, and then we're just doing a square root on it to calculate that distance. You can also use the distance formula. That's also a popular method, but this is the most popular method for KNN. It does it more efficiently, but it's the same thing as using the distance formula to calculate 2 different points. So you just calculate all these different points, and after calculating the points, we sort the distances. We sort each distance. So if you notice, I sorted the distance now into the 6 values. So let's say this distance corresponds with this. Oh, wait. Let me make it more realistic. This distance corresponds with this with this with this with this one. Okay, but you get the point. So let's just say these each correspond with their distance between, the data point here. So after we sort the distances, we're going to perform another step. But so far, does it make sense what we're doing here? After calculating each distance, we're sorting the distances. Does that make sense so far? Can I get like a thumbs up or something?
Yeah, that makes sense.
Okay, good. Okay. So, once we sort the distances, we now move on to the next step. So for classification, right, we use a system called majority voting system. So in the majority voting system, what we do is we calculate the mode of, so the mode, okay, first of all, who knows what mode is? Have you guys heard it in your
The most
classes?
recurrent number.
Yeah, frequency of the number, right? So let's say the mode of let me give a data point, okay? Let me give an example of data. Let's say this is your data set. What's the mode of this?
It's 1.
Yeah, correct. 1. Why?
It's the most frequent date, like it's one of the most frequent datas in there.
Yeah, 1 is the most frequent, right? It comes to 3 times. Okay, good job. Okay. All right. So what we do here is we calculate the mode of a certain amount of K values we're getting, right? K values are basically the amount of data points we're looking at a time, right? So in this case, let's say there's 6 data points here. Let's say we're getting the mode, right? And we're getting it for a K value of 3. Okay. So let's just say I'm just making up these values. These are not the correct ones. Mode of 1, 0, and 1, right? It only takes 3 data points. Does this make sense why we're using K? So right now, does that make sense?
Yeah, makes sense.
Okay, yeah. That's how that works. Okay. So after doing this, right, I'm giving this example here. So let's say in class 1, right, we have 3 times. And then in class 2, we have 2 times. So if we say that K is going to be 5, then it checks this here and it sees how many times is this like point close to it. So for example, let's say that we have like an apple here. It's gonna take this apple in consideration as well. But it's seeing how close to it is it compared to like a threshold value that it calculates, right? Once it calculates that, it sees which points are closer and then does the sorting and takes the um, remember from back here, it takes like the K value. So let's say it takes K of 3. So it takes these 3 and it's comparing how many apples are there in that and how many bananas are there. Okay. So in this case, in this example, this is not like tied with this, but we can tie it up with this. So in this example, we have 5, the K value of 5, right? So let's say after doing our sorting, right? We just after doing our sorting of random data, right? I'm gonna do A for apple and B for banana. A, B, B, B. Okay. And we'll do a K value of 4. Okay. 1, 2. Actually, we'll do it of 5. We'll do 5. Okay. We'll do these 5 values here. And it does a voting system here. So now we're creating a data set. Let's create a data set for this value here. So we have, let's say A is equal to 1. So A is equal to 1, right? So we'll say how many ones are there? There's 1. Okay, B is 0. 0. Then what's next? A is next. That's 1. What's next? B. 0. What's next? 0. Okay? Now we create this data set, and now what are we doing? We're getting the mode of this. What's the mode of this data set I have right here?
0.
Yeah, 0. Good. Okay, and that's how our model makes the prediction. It looks at what's nearby, sorts it out, right? We calculate the distance, sort it out, and then it's calculating the mode, right? Based on a certain threshold, right? We're saying the threshold is the K value, and in this case, we said K is equal to what? 5, right? We're taking those 5 points, looking at it here, from the sorting data, and then seeing what that result is, right? So it's basically using a voting system to calculate this. Does that make sense to everyone?
How does K equal 5?
Oh, so K is a value we set. It doesn't matter what we set. I could also set K is equal to 3. Okay, let's go back to this. Actually, let me just everything. Yeah, let me go back to this. So K is something we set. Let's say I set K is to 3. Then we can look at these. Well, based on this data, right, we get the mode of this. We can create a data set. 1, 0, 1.
Yeah.
Sorry, what was that?
It's not problem. This is
Hanish, what was that? Okay. I wasn't sure if you were meant, did you mean to mute and talk or? Okay, not sure. Okay, so basically what it is, right? In this case, it actually uh says it as 1, so it says that it's closer to an apple, right? So it depends on your threshold value you want. Usually you do like an odd number, so it does like the voting system properly. Because if you do an even number, right, it's not gonna properly do the voting system because there could be like two A's and two B's. Does that make sense? But that's how it works. So the K value is something we set. Does that answer your question?
Yeah, it does.
And to be clear, like the K value is just it just tells us how many like data points we're taking, right?
Yeah. So basically what we do here, let me go back to the so let's say here K is 4, okay? So I'm taking these 4 data
Yeah.
points. After sorting it, I'm taking these 4. And then
Uh-huh.
I'm creating that mode equation thing that I did, right? So let's
Mhm.
say yellow is 0. Okay, so we have 0, comma 0, comma 0, comma 1, right? And let's say red is 1. Okay? We create this and then we calculate the mode. Obviously the mode is going to be 0, right? Because there's 3 zeros here. And it makes its prediction as bananas. Does that make sense?
Yeah, that makes sense. But what happens if they're both the same, like you said at the beginning?
Yeah. So if they both have equal amounts, right?
Mm-hmm.
Okay. So usually you set the K value to a odd number. So you wouldn't do 2, 4, 6, 8.
Oh, okay.
Reason
Yeah, that
being,
makes sense.
yeah, okay, yeah, right. Because if it's an odd number, you're never gonna get that problem, right? Let's just pretend, yeah, you're never gonna get this problem because you see there's 2 reds and 2 yellows, and there's like this area has to be different, right?
Yeah, okay.
Yeah. Okay, perfect.
Yeah, thank you.
Yeah, no worries. Okay, so this one, KNN is probably the easiest model to understand, really. Um, so does anyone have any questions on how this works? We're gonna do a code example after this. We're gonna get into regression of this tomorrow, but today we're just gonna cover classification. So does anyone have any questions on how this works? Or if you don't have any questions, can you just let me know so I can move on to the next thing? Okay, all right. Let's move on. Okay. So now let's move on to the code. Okay, yeah. So I'm gonna start explaining the code now. Who wants to give it a shot on what the libraries mean? Remember, we use sklearn a lot, and I'm sure by now you guys are familiar with a lot of the things in here. So I want you guys to explain to me what at least one of the libraries that you're using here is.
The sklearn pre-processing, is that the one which like makes the values into numbers?
Yes, good. Yeah. You're correct, but in this case we're importing a different thing. But you are correct on that. You can use sklearn.preprocessing to import in the encoder. But this time we're using something else. Yeah, good job. Um, Padma, yeah.
The is the sklearn.neighbors the one that like figures the k-neighbor?
Yeah. Yeah, good. Good. Yep, correct. We're importing that from neighbors, getting that model. Yeah. Good job. Who else?
Training test split from SK learn model selection is just like splitting the data into training and testing portions.
Could you say that again? I couldn't hear you.
The train test split from the model selection is just like for, I guess, splitting the data into training and testing data portions.
Right. So that's learn model selection. We're just doing the train test split. So if you guys remember from a couple of classes ago, we did this train test split to like show you guys. So in this case, I used a 70-30 split, right? So it's using 70% of the data for training and 30% for testing because you want to test on data the model hasn't seen. Usually you don't do this really with a small data set. I just kept this code in. So you guys, when you work with bigger data sets, you do it because with smaller data sets, it messes up the code. So I'll go more into it later, but good job. Who wants to get the easy one? Pandas. Anyone?
It imports your data set and
Yeah.
allows the code to read it.
Yeah, good job. Thank you, Dia. Okay. Yeah. Good job, everyone. Yeah, you guys are all really accurate on it. And then metrics is just the accuracy and classification reports that we get from the model. We're just importing that to use it for our results, for our results. Yeah. Okay, let's start this. Okay, so right here, I'm just using some data that I created. It's not a CSV, I just like randomly created this data. Um, Here I'm just creating this data, and then all this code does is it just creates it into that CSV. So if you remember, like pd.read CSV, and then we put the CSV name, all this does is just it like turns whatever this in to like a CSV so the code can read it properly. That's all it does. Nothing too complicated. We're just passing in the data from it to convert it into a CSV kind of thing, structure. Okay. And then who wants to tell me this? This never changes. What is this?
You're selecting the x-axis values and the y-axis values.
Yep, good, right? Our independent and dependent variables. Good job. Correct. So we're just doing that. So I have age and annual income. Remember, when you work with x-axis, you have to always do double brackets. Good. Good. Remember, I kind of confused you guys yesterday with this. You guys can also just use this code here, df.drop, and then you can drop purchased, and it'll just do the same thing. That's it. I just wanted to like go over that yesterday because I know that some students were a little bit confused on this part of the code, but that this code and the code like I just did is the same thing. It's just if you have like, let's say like 50 others of this and you just want to have your y-axis as purchased, you don't want to go in the code and then write 50 times, whatever you have here. You just want to just drop one thing and then it uses the rest. That's why you would use that shorthand code to do it. But this is just easier for now. Okay, cool. We have our x value and our y value. Okay, now let's talk about this. This is your x train, x test, y train, y test. Uh, all this does here, this code, let's say we have a database of 100 files, okay? Let's say we take from here 70%, right, which is a 70 to train the model, okay? And we take 30 points here to test. This is new data that your machine learning model that you created has not seen before, right? It's totally new. You're training this model with the 70 data points it has seen. So it's already trained now. Let's say after you create your training model, right? Let's just say this is your trained model. After you create your trained model, now you're feeding this model a new data set it hasn't seen. And based on this, you can now see if your model is accurate or not. So that's how this code works. It's just splitting the data so um, you have a stronger database to use for your model. That's it. There's nothing too complex on it. Yeah. Okay. So here. Okay. So here I'm just scaling the models here. You don't have to worry too much about this section of the code. It's not the most important right now. So we'll talk about more of the specifics of this later. All it's doing is training, it's just creating a separate data set here. That's it. And right over here is where you're actually creating a KNN. And if you notice here, what are we doing here? You're setting your K value here. You're saying the number of neighbors you want, right? So what does this do? Who wants to tell me? Just give me what does a K value do?
It
Anyone
tells
want to
the
give?
code to use the three nearest data points to like the new data point
Yes.
to decide which category it fits into.
Yeah. Good job. Yeah, that's exactly right. So in this case, it's telling the model to look out for the top three, right? After we sorted out from lowest to highest distances. Yeah, good job, Dia. Pretty accurate. What is this code doing? We've seen this like hundreds of times. What is this code doing here, guys?
Does it train the
Yeah,
model?
yeah. Who is that?
Pragyat.
Okay, yeah, good job, Raket. Yeah, it trains the model. Right. So we're using the X train scaled and then the Y train. That's just your training data set. You don't really need to worry about this. Honestly, I just wanted to show how it would be. But since this is like, okay, I'll go into that later. I'll just change these to X's and Y's for now. So X, Y for now. You don't really need to know too much on this yet, but once we get into our research stage next week, I'll explain more about it. Okay. So yeah, correct. We're training the model and we're using this age, this X values we gave it and the Y values we gave it. We're feeding in this data. Okay. Then who wants to tell me what this does? Hint, it's in the code. It tells you what it does. Who wants to tell me?
Does it predict
It just
the
makes a prediction.
Yeah, good job. Both of you, good job. It just makes a prediction, right? It's after we train it, right? We sort so the training stage, what does it consist of, right? It does the sorting, it does the James, the last few minutes as I joined. Seems to be can you please share the main points related to KNN? 'Cause- Yeah, yeah, Liam, it's actually pretty easy to understand, so I'll go over it one more time after I explain the code. So, okay, where were we? Okay, so the KNN here, it just predicts it. So in this code, what it does, it's what? It's calculating the distance, it's sorting the data, right? And this is where it's actually using the K neighbors, right? In the equation, right? It's getting the K neighbors and doing what? The mode calculation, right? And then it tells, yeah, no worries, Liam. And then it tells you the output of whatever that is, okay? Um, so here I'm just printing the accuracy of my model and the classification report here. So all this is I'm getting the accuracy report from the Y test and the Y predict, and then the Y predict here. That's basically this. I'm getting it from here, and then the Y test. So not you don't really need to understand it. All it's doing is printing the accuracy of my model and the classification reports. This code is never going to change. So there's nothing like logical you need to know. It's just that you need to know this is how you use this code to export out your results for this type of model. And right here, I just created a sample data set and fed it into my model that I created, and it makes a prediction. So in my case, it made a prediction of the person purchased um purchased based on the data I fed it. That's it. I just wanted to give a live demonstration of how it works. So now I'm gonna actually rerun this model. Okay, yeah. Now, do you guys remember how the accuracies were one and how all the other values were one? Well, that means my model didn't really work because okay, yeah, I'll get to the results section. Yeah, I'll explain that in a second. The reason that all the results before were one is because I took out 70% of my data. No, I took out 30% of my data, right? So that basically takes out most of my data points. So the model didn't have enough points to make a accurate decision. So it just made all my results into one. So whenever you see like all results like 0 or 1, it means that you messed up somewhere with your data and you don't have enough data. So that's where it's doing that. But if you notice now, the prediction also changed to not purchase. But if you notice here, our accuracy is very low, like 33%. Does the score up? Yeah, it usually, since in most cases a score of 1 is never possible, really, it does indicate overfitting. Yeah, that's correct.
How many data points do you need exactly? Like to have a minimum have an actually like
Yeah,
accurate data
model.
set.
Yeah, makes sense. So usually what you would need, it depends on what you're trying to do though. Usually you would need hundreds and hundreds of data points. Like for me, for my machine learning models, I used around 2000 data points. So that's for me, right? But you would need at least more than 100 or something around. I would say like the sweet spot if you're not working with anything too crazy, like around 500 to 300, like that range. But if you're working with something like medical data, you would need a lot more than 1,000, I would say.
Yeah, that makes sense. Yeah.
Yeah, because
Thanks.
you want to be as much accurate because the models learn from data, right?
Yeah,
Just like
yeah.
a student learns from resources. Like if the student just uses like one textbook, I mean, I guess he can learn whatever that textbook provides. But if you give the student a variety of textbooks like math, science, English, then he can answer and understand more things, if that makes sense.
So the more data you give it, the more accurate the like it
Yes.
would come out basically.
Yes, yeah. So the reason why this accuracy score is really low is probably because I don't have a lot of data, so the model can't really understand much from what I give it. But that's how this works here. Okay, let me explain about the meanings of each one of these. Okay, so the most important one you would really need to know is precision and recall here, and accuracy. The other ones, they're important, but not as important as the precision and recall. So, what is precision and recall? So basically, the precision is the true positive. Wait. Let me just make sure one thing. I'm pretty sure precision is true positive. Okay, yeah, sorry. So precision actually is the true negative, and precision is the true negative, and recall is the true positive. Anyone heard of these two terminologies I'm using here? True positive, true negative.
Is it like the highest and the lowest?
Include all of that. Yes, the correlation matrix does include that. What was that?
Is it like the
Could you
highest and the lowest?
highest and lowest? Okay. And okay. Okay. Did I go over confusion matrix with you guys? I think I did in a class, right? Correlation matrix include. Correlation matrix does not include all that. It's you would work with confusion matrix to understand. Yeah, okay. Yeah. Yeah, Padma, yeah. It's confusion matrix. Can you guys see my screen of this?
Yeah.
Okay. So I'll go over confusion matrix one time so you guys like understand the results of this. Okay. So basically, the true positives, if you notice, there's true positives, false negatives, false positives, true negatives. So let's take a data set. Let's say it's cancerous, C, and non-cancerous, okay? Let's say 1 represents cancerous, 0 represents non-cancerous, okay? Um, a true positive means that the model predicted as cancerous, okay, so cancerous and cancerous. So that means it created a correct representation of data. It said, yes, the model predicted the data is cancerous and it actually is cancerous. So that's a true positive here. A true negative is when um true negative. It's like the same thing, but now it's for the non-cancerous. So the model predicted as non-cancerous and it actually is non-cancerous. So it is true that it is negative, right? That's our position here, our true negative. So that's how true positive, true negative works. So what's false positive, false negative? Well, false positive and false negatives, it's basically false positives is it predicted as negative, but it actually has cancer, right? It predicted that the data set is non-cancerous, but the person actually has the cancer. Okay, that's a false positive. A false negative would be the model predicted the person has cancer, but he actually doesn't have cancer. Does that make sense to everyone? How it works?
Yeah, it does.
Okay, good. True positives for data whose expected and actual result. Yes. Yes, correct. That's correct. Yeah, Danwin, go ahead.
So could you repeat how we figure out if a value is false positive or false negative or something like that?
Well, we don't really do any of the machine does all the calculations for it, but you just need to understand how to interpret what it means. So do you understand what true positive, false negative, false
Mm-hmm.
positives, and true negative? Okay, good. As long as you understand that, you should be fine.
Okay.
Yeah. Okay. See. Yeah, F1 score is basically what this precision and recall is telling you. It usually just tells you if your data is imbalanced, and if we can look from it, it shows that our data is slightly imbalanced. Well, actually, a lot imbalanced. Um, yeah. What else do you guys need to know? And accuracy is just how accurate your model is. And all these different types of accuracies and different things, it's just saying the same thing. Um, there's nothing too much, so we won't get too much into this yet. I just don't want to confuse anyone. So precision is true negative, recall true positive, and that's what it tells you from this. Okay, so what I want, we have 15 minutes. Who didn't present yesterday? I need the people to present. Who was here 2 days ago and didn't present? Oh, before that, let me just quickly go over like how this works to Liam, because I know that he wanted to know real quick. So Liam, I'll just run through it really quick. But just watch it again. Yesterday I already presented weight such it. Why don't data split 99% true? Because Hmm, well, okay. 99% rank. Okay. That's not exactly the case, Padma. So if you do 99% training, right? what that does is you're only leaving 1% of the data to actually test. And that's not really helpful in your testing at all, right? You want to have a kind of balanced set. You need enough data to actually test. Um, with bigger data sets, right? Let's say you have 100 pieces of data. If you do 99 training, so you have 99 just to train the model. So you're learning 99 textbooks, right? But you only take one test. But that one test, you can't really make a judgment based on one test, right? Because you're only left one data to train. And you can't really tell if your model works or not with one data set. Does that make sense? What I'm trying to get at? So the training, it doesn't really work in that way. I needed help on getting the CSV into Jupyter. Prakya, oh yeah, I'll help you. So today, I can start. Okay, Saranya, what you can do is you can share your screen and you can just type out. Okay, how about you just type out what you want to say, and just share your screen and point to it. That's fine. Okay, so Padma, let me break it down a little bit more. Okay. So we have the ML model, okay? And then we're feeding the machine learning model the 70% of data. When you're working with large databases, really big databases, you really want to do this train test split method. It's a common practice in this type of field. Usually, it's 70-30. That's the usual amount that most people use for this practice. Then the model learns on this. Remember, a machine learning model, if you remember from our first class, what I said, the second stage, the inference stage, is the machine learning model makes a prediction on what? New data it hasn't seen. It wouldn't make sense if you don't, let's say you don't split the data, right? You're just giving the machine learning model the same data again. Obviously, it knows what the answer is because what it already has that data, right? But if you give it a new data and it's only learned on whatever data and you don't even test it, then it's going to completely give a wrong answer. It's going to be harder to do, right? So you want to let the machine learning model train on these small amount of data points and still have enough new data for it to learn and improve. And then you can make a judgment on whether you need to change or tweak some features. So that's how this works. So this 30% of new data is coming from our original database. Well, if that's the case, then. But why isn't 17? Since there's, yeah, 60-40, 80-20. Those are all standards. It really depends on what you want to do. 80-20 is actually used a lot more than 70-30, but there's also a validation data set. You'll get more into validation data set when you get into neural networks. But 70, yeah, what she's saying is right. There's other common practices. It's not just 70-30. There's more 60-40, 80-20, like you said. 80-20 I know is used more than 70-30. 60-40, I've not seen it as much as 80-20 and 70-30. But yeah, there's a lot of different practices like that. Okay, cool. All right. I'm gonna stop. Oh wait, never mind. Let me explain this real quick. So basically, Liam, how it works is you're calculating the distance between each of these points here using this a distance formula. I'll show you the formula in a second, but you're calculating the distance of each one, and then you're sorting the distance like this, and then you're setting a k value. So let's say the k is 3. Then it takes 3 data points, right? The 3 data points from the top. So we're sorting it from lowest to highest, and then we're using this equation here for the inference. The equation looks complicated, but it's super simple. Basically, what it does is it creates a table like this, right? We have k is 3, so we use 3 of the values. So let's say yellow is 0, okay? And red is 1. So we have 0, 0, and 0. Okay. And then we calculate the mode. You know how to calculate mode, right? Mode is the answer of the most frequent data point. What's the most frequent data point? 0. So it says that the data point is a banana probably because it's close in based on crunchiness and redness, it's close to a banana compared to an apple. Okay, let's say in another case, K is 5. Now we're taking these. Then we can create another table. 0, 0, 1, 1. Then we can calculate the mode of this. Well, it's still going to be bananas, right? Because that's 3 data points. So we have 0 as that. So KNN believes in this formula that classes, data points are closer to the classes that they represent, right? So in this case, we're using crunchiness and redness to see which data point it's closer to, and it makes a prediction on that. That's how it works in a really fast way, I guess. Yeah, so this is a formula you can use. It's the same thing as the distance formula, right? It's just using a different formula. This is the most popular for KNN, but you can also just substitute in distance formula and do the same thing. But yeah, this is how it does this. Just saying the K is going to come. Yeah, yeah, yeah. That's exactly right. That's a good explanation of it. Okay, yeah. All right. I think we have time. We'll do like we'll work with this data set tomorrow, guys. We'll be coding it tomorrow. Today, I want to finish up the rest of the presentations. So, Sarnia, I think you said you had one, but you couldn't unmute. So, do you think you can just share your screen and type in the chat what you want to say? Okay, perfect. Go ahead and start sharing. Okay, yeah, you just need to download that zip and extract it. I'll help you after class, Prakya.
Okay. Were you not able to see the chat while presenting? Okay, that's fine. Just share your code and
what you can do is you can go to Google Docs or something and just type out what you want to say. But it's fine. Actually, don't worry about it. We can do the presentation next time. That's gonna be a little bit tough. It's fine. No worries. Uh, you don't have to worry about presenting today then. Yeah. Okay. Anyone else need to do their presentation today? Oh yeah. Go ahead and share your screen. Prakya, go ahead and share your screen. I'll help you solve that issue right now. Prakya, are you there? Okay, it's fine. I'll help him. I'll text him later and then I'll ask. Yeah. Okay. Anyone else have any questions that I can answer before we end the meeting? Yeah, go ahead, Papa.
Sajid,
Yeah. Yeah, we'll learn image classification. Yeah, we're gonna be doing that next week. Is that your only question? Okay, yeah. Okay, thank you guys for joining. There's nothing else to do today. If you guys have any questions about any of the topics, please reach out to me on Discord. But thank you all for joining today.
Thank you.
Bye, guys.